Hello, I'm Akshat Kochak, and today we are discussing the internal test third. Uh, so, question number first is in stars and matrix multiplication, the number of multiplication needed to multiply two 2x2 matrices is so it will be 6. So, the second question is the Huffman coding. The Huffman code is type of. So the Huffman code is type of lossless comprehension algorithm. Question number 13. In Krustal's algorithm, what is the time complexity of for sorting the edges of graph? So O of order of n log n will be the right answer. In Prim's algorithm, what is the time complexity for the finding the minimum weightage for the vertex? Order of n is the time complexity for finding the minimum weight age for a vertex in Prim's algorithm. Question number 5. Depth first search DFS can be used to find the longest path between two nodes in a graph. Yes. Breadth first search can be used to find the shortest path between two nodes in a graph. Question number 7. Dynamic programming can be used to solve problems that exhibit optical structure and overlapping sub problems. Question number 8. The matrix chain multiplication problem can be solved using dynamic programming. So, 9 question is the longest common subsequence problem can be solved using dynamic programming. Question number 10. In Strassen's algorithm, the matrices to be multiplied are divided into two equal parts. The running time of Strassen's algorithm is order of n to the power 2.81. Question number 12. Huffman codes are prefix codes that means that no code prefix for any other code. So this will the right answer. Question number 13. We don't have to see any other because we got the right answer there only. Question number 13. The minimum number of the bits required to represent the symbols in a set using the Huffman code is less than a number of symbols is the right answer. So what is the time complexity for the standard matrix multiplication algorithm? So order of n to the power 3 is the right answer. In Starson algorithm, what is the base case for the recursive algorithm? So they have come the answer which is with matrix 2x2. Question number 16. The Huffman code assigns shorter code to uh, symbol with high probability. In Kruskal's algorithm, how many times are edges or graph sorted? So only once. Prince algorithm can be used to find the minimum spanning tree of undirected graphs. The time complexity of BFS is order of n. The time complexity of DFS is order of n. Question number 21. The time complexity of the dynamic programming approach for solving the longest common subsequence problem. So it will be O to the power O n to the power 2. The matrix chain multiplication program, the number of matrices to be multiplied is given as an input to the algorithm. What is the time complexity of the dynamic programming approach for solving the matrix chain multiplication problem? So it will be order of n to the power 3. Question number 24. Which of the following algorithm use a greedy approach? So Kruskal algorithm uses the greedy approach. The longest common subsequence problem can be used to solve question number 2. DNA sequencing problems. Question number 26. The running time of Strassen's algorithm is faster than the standard matrix multiplication algorithm for matrices size of the size 4x4. The in the Huffman code, the average length of the code word is less than the number of symbol. What is the time complexity of dynamic programming? What is time complexity of dynamic programming approach to solve the matrix chain multiplication problem. So it will be O to the power n3, I guess. Yeah, O to the power n3. Question 29. What is the maximum number of subproblems that need to be solved in a dynamic programming approach for matrix chain multiplication problem? So n to the power 2. Question number 30. In the dynamic programming approach to solve the longest common subsequence problem, what is the recurrence relation used to calculate the length of the LCS? So here option number B is the correct answer. Question number 31. In the dynamic programming approach to solve the longest common subsequence problem, what is the time complexity to print LCS? So O to the power n is the right answer. 32. What is the time complexity of the dynamic programming approach to solve the matrix chain multiplication problem for a given sequence of n matrices? So order of n to the power 3 is the right answer. So what is the time complexity for dynamic programming approach to solve the matrix chain multiplication problem for a given sequence of n matrices of using um, memoization? So the right answer would be uh, order of 2 to the power n will be the right answer for this. Question number 34. Which of the following algorithm can be used to solve the longest common subsequence problem? So dynamic programming can be used to solve the longest common subsequence problem. Question number 35. Which of the following algorithm can be used to solve the matrix and multiplication problem? So dynamic programming can be used. Question number 30 is in the dynamic programming approach to solve the matrix chain multiplication program, what is the minimum number of scalar multiplication required to multiply the n matrices? So option number B, m0 n minus 1 is the right answer. Question number 37. In the dynamic programming approach to solve the matrix chain multiplication program, what is the minimum number of scalar multiplication required to multiply a chain of length n minus n? So uh, here option number B is the right answer. Question number 38. Which of the following is not subproblem of the dynamic programming approach to solve the longest common subsequence problem? So option number D is the right answer. The dynamic programming approach to solve the longest common subsequence problem has a time complexity of uh, order of n to the power 2. So what is the difference? Question number 40. What is the difference between Prim's algorithm and Kochak algorithm to finding the minimum spanning tree of the graph? So Prim's algorithm start with an arbitrary node and adds the shortest edge from the set of available edges, while Kochak algorithm start with the shortest edge and adds edges in increasing order of the weight. Yes, it is the right answer. Prim's algorithm uses a priority queue to select the next edge to add to the tree, while crucial algorithm uses the disjoint set data structure to maintain the set of connected components. Yeah, this is also true. Prim's algorithm always produces a connected tree, while crucial algorithm may produce a forest of disconnected tree. Yes. So all three options are correct. So we will go with the option number D, that all of the above are correct. Thank you.